So we are solving systems. Algebraic. Algebraic. All right, so y equals 2x plus 3 and 4x minus 3y equals 1. So substitution, you always want to take one equation and get one variable by itself, which in this case you already have, right? Which one's already by itself? The y. So I don't have to really do much work. If y equals this whole thing, I'm sorry. How about I write solving by substitution? So you know what we're doing. Okay. So solving by substitution, if y equals this whole thing, I can take this whole thing and put it into the y in the other equation. Okay, so now I have 4x minus 3. Yeah, this is algebra 1 stuff, so hopefully you remember it. Times 2x plus 3 equals 1. Okay, so what happens is now instead of having an x and a y in the same equation, I have just x's. And then I want to solve for x. So distribute the negative 3. Be careful, make sure you distribute the negative with it. Combine like terms. Hey guys, you can't be talking in the background because the video is going to pick up all your talking. So add over 9. And x equals negative 5. Okay, so that's just one solution to it. What do I do to find the y? Yeah, go put it back into one of the originals. Don't put it back into anything that you mess with. I'm going to go back up to this one right here. Y equals 2 times negative 5 plus 3. So negative 10 plus 3. So I got negative 5 for x. And I went back up to here. You put it into either one, but this one's already y equals by itself, so I went to that one. So my answer, we write that as a coordinate point, negative 5, negative 7. What would this system be called?
What are my options?
Dependent, independent, inconsistent, consistent?
Inconsistent.
That's a good point. Yes, because there's one point. Okay, this is the point where the two lines would intersect. Okay, so instead of graphing it to find negative 5, negative 7, we're using algebra to find the coordinate. Not bad, right? Every time you say, hold up. Are you ready for the next one?
How do you know you know?
Because you got one solution. So remember, we have one solution, infinite solutions, and no solution. So one solution is always independent and consistent.
So you just have the point where you have cross.
Yes. That's it. Which is the solution to this system. There's only one solution. So remember how we talked about when you have a line, how many solutions does a line have? Infinite, right? Everything on the line. But in this case, I have two lines. How many solutions to this system? One and only one. Because that's where they cross at. Okay, so only one solution to this system. Okay, let's do another one. 3x plus y equals 7. 4x plus 2y equals 16.
So we went to the top one, y by itself.
So you need to pick one of the equations to get either the x or y by itself. You can pick anything you want. Since that top one already has a 1y, I'm going to take this one. And I'm going to solve for y. What would y equal? Good. Negative 3x plus 7. So you could solve for x if you wanted to, but you would get ugly fractions. If we can avoid, we want to avoid. Okay, so now I got y by itself. So I take this whole thing and I put it into this y right here. Make sure you go to the other equation. Don't go back to the same one you just solved for. You do get calculators on this unit, FYI. I think actually this whole 6 weeks you do. So that's not the next one, unit 5. Well, but these are easy. I mean, when you have you're going to have fractions, you're going to have decimals.
That's true.
So you probably want
I
one.
can't fraction.
So this becomes negative 6x plus 14 equals 16. Negative 2x equals 2. So x equals negative 1.
I didn't feel it when I got there.
You did it.
I did the other way.
Oh, on this one? Perfect. It's fine. You can do either one. So then I'll come back up here and I'll plug in negative 1 to the x. So y equals 3 plus 7, which is 10.
Can't.
Yes, ma'am. What kind of system is this if I classify it? Independent consistent.
Can't you plug the x into the 4x plus 2y?
Yes, you can go back into either one of the originals. Yes.
So hold up. If they give us like question this early, just do this, we can answer.
Yes.
Okay.
Were we ever going to go for it?
Yeah, so yesterday we solved by graphing to where you took both of these, got them in y equals mx plus b form, and you graphed them to get that point.
Wait,
This is just without a graph. So there's multiple ways to solve a system. We have solve by graphing, we did that yesterday, where you graph it and you would get this point. We have solving by substitution, got negative 110, and then we have solving by elimination, which we're going to do in a second.
Can we all just all do this way?
It's going to tell you instructions. So it'll say, some will say solve by substitution, some solve by elimination, some solve by either substitution or elimination. Because some of the elimination ones get gross, and so it might be easier to eliminate. Okay, let's do a different substitution. Let's do this. Okay, number 2, 4x plus 3y equals 4. 6x minus 6y equals negative 1.
Well, we're in different ways, like today.
Yes, so today you have substitution and elimination. So this is the only other substitution one I'll do, and then we'll go do some elimination ones. Okay, so on this one, there's no easy equation to pick and solve for x or y. So which one do you want to do?
The bottom one. The bottom one's gonna be
The bottom one?
yeah.
Okay.
The top one.
I think you picked the hard one.
Yeah.
I'm gonna go to the top one.
The bottom one.
Okay, so on the top one, guys, listen. 4x plus 3y equals 4. You want to solve for x or for y? X? Okay. So I'm going to subtract. What?
That one's hard. I'll give you 2.
You're going to get the same answer, whatever you do. Let's solve for that. 3y equals negative 4x plus 4. Divide by 3. Yes, you get fractions. You're going to get fractions on either one, though, so it doesn't matter which one you pick here. 4 thirds x plus 4 thirds. Okay, so I have to take that whole ugly thing and put it into this y right here. Okay, so just be careful when you're writing this out. 6x minus 6 times all of this, negative 4/3 x plus 4/3. And honestly, even though you can use a calculator here, I'll still see errors. All right? You're distributing a negative 6 to both fractions. So it goes into the negative 4/3 and also to the positive 4/3. So this is 6x plus, what does that become? 8. Good. 8x.
Wow.
Do you need me to show you why?
No, I got it. I was going to say 24.
Minus 8 equals negative 1. Okay, so you can use your calculator to do negative 6 times negative 4/3, you'll get positive 8. Negative 6 times positive 4/3, negative 8. So 14x equals, what, 7? X equals 1/2. Okay, you can take this 1/2, you can go back to one of the originals. I sometimes go here, although technically we always say go back to the original to make sure it's correct. So let's go to, it doesn't matter, let's go to the first one. So 4 times, I'm going to put 1/2 in for x, plus 3y equals 4. So this one's not too bad. 4 times 1/2 is what? 2. Subtract the 2 over and we get 2. So y equals 2/3. So 1/2, comma, 2/3. Independent and consistent. Good. All right, are we good on substitution? Okay, I see a couple of people still writing before we go to elimination. All right, anyone still writing? Okay, so let's do some elimination. Okay, so when you're doing, well, yeah, the first one is going to be. So elimination, you're looking to eliminate one of the variables. So you want to vertically align your equations with the x's, the y's, and then the numbers. So in this case, it's already nicely done for you in that you have a positive y and a negative y. So where you're adding going down. So it's basically like a big math problem. Okay, because I know some people get confused as to, well, am I adding it? Am I subtracting it? What am I doing? So I'm going to have, I have 2x plus 3x, which is 5x. And then this is why we call elimination. The y's are eliminated. And that equals, again, it's 1 plus 14, so 15. So what does x equal? X equals 3. So go back to one of the originals and plug in 3. So I'll go back to the first one. 2 times 3 plus y equals 1. 6 plus y equals 1. So y equals negative 5. You know they won't always be that easy.
Nice.
Anyone still writing that one? Oh, yeah, we can. Sorry. sorry, so that would be the same thing, independent, consistent.
We always have to recommend.
I don't know, I think on quizzes it just says, it'll say like solve by elimination. It will specifically say classify the system and determine the number of solutions, which this one is solution. But I think on elimination, there's a couple that do turn out the other way, so we'll do one of those. Okay, so the next one. So this is where it gets to where you have to do a little bit more than just add straight down. I know, crazy.
Wait, why can't I just add it?
So before you add straight down, you want to make sure you can eliminate one of the variables. And so you can't eliminate one, so we have to create that elimination. So when you're looking at this problem, if I was to add straight down here, I would get 14x, and here I get 8y, so nothing eliminates. I want to pick one of these to make the same, one positive, one negative, to eliminate. So do you want to pick the x's or the y's? The x's? Okay. So what's a common number that 6 and 8 both go into?
24.
Okay, how do I get this to be a 24?
4.
Multiplied by 4. The whole thing gets multiplied by 4. You can put the 4 in front or behind, but don't forget to multiply every single piece by a 4. So let's write the new one over here. So I don't run out of room. No, I'm going to write the new one down here. So 24x plus 12y equals 24. Yes, so on this one, if I multiply this by a positive 4, it's going to give me a 24x, which does not eliminate. So I have to make this a negative 4. Oh, yes, thank you. Okay. Let's try a negative 3 instead. There we go. So that when I distribute, it becomes a negative 24x, because that's what I want to eliminate. Negative 15y equals negative 36. So again, this becomes a big math problem. So x's go away. Negative 3y equals negative 12.
Y equals 4.
So y equals 4. Go back to one of the originals. So I'm going to go to the first one. 6x plus 3 times 4 equals 6. So going back to the very first equation. 6x plus 12 equals 6. Subtract over the 12, which would be negative 6. So negative 1.
Oh my God. I'm not paying attention.
Bless you. Bless you.
Anyone still writing that one? Okay. So I want to do 2 more with you that are a little bit, that come out a little bit weird. No, no fractions. Okay, which variable do you want to eliminate?
Y.
The y. Okay, so I have a negative 2y. What does this one need to be? Positive 2y. How do I, or what do I multiply to get positive 2y?
Negative 2.
Negative 2. Yes. Yes.
If it says like negative 2y plus 4x, you just like change them around.
Yes, move them around because you want to align the x's and align the y's.
But it doesn't really matter.
Oh, I
Wait,
see
but then
it.
the X's and the Y's
I see it.
So this one stays the same, 4x. Guys, pay attention here.
They both cancel now.
So this one becomes, make sure you multiply all the way across. Negative 4x plus 2y equals positive 2.
Oh, I see.
So when I add down, 4x minus 4x is nothing. Negative 2y plus 2y is nothing. What's on the left side? 0 equals what? 7. Good, no solution, because that is not true. What does no solution mean about the lines? What would the lines look like?
Parallel.
Parallel. Lines are parallel. And we call that inconsistent.
Will that ever be all the numbers?
Yes, we're going to do that one right now.
Oh, we can't just all the numbers.
But I do want to show you, I forgot to show you how to write your answer yesterday on that. I had it written down, I don't know what I was thinking. Plus 10y. So last one, it is a 7, yes.
What? I see it.
So which one do you want to eliminate?
Guys.
The y's? Okay, so I have a 10y. I need this one to be a negative 10, so I multiply by a negative 2. So negative 6x minus 10y equals negative 14. This one stays the same. 6x plus 10y equals 14.
So everything cancels out. And then x.
So when you add down, these cancel, you get 0 on the left, and you get 0 on the right.
Doesn't matter what you say.
What does that mean about the lines? They're the same.
They're the same.
Remember we said infinite solutions. What's our system called? Dependent, consistent. Okay, here's the part I forgot about yesterday. So I want you to write it here and we can go back and put it in your notes from yesterday. If you get dependent and consistent, we actually use set builder notation to write our answer. Okay, instead of just an x here though, we have x, y, because we're talking about solution to an equation. Okay, so we say x, y, you put your line, and then I just put my equation here. So in this case, these two equations would end up being the same if you got them in slope-intercept form. So I'm just going to put 3x plus 5y equals 7. So not difficult. I don't know, I forgot it yesterday for some reason. So if you go back to one of your ones from yesterday and you look at it, anything like, let's say we got negative 4x plus 7, and they were dependent. So you would do the same thing. X, y, and then you put your equation. That's it. Okay, so the worksheet you have in front of you, that is your first